Welcome to Decrypt's Deep Learning playlist. We live in a world where we are surrounded by deep learning algorithms. From social networking to driverless cars to movie recommendations, deep learning algorithms influence our lives and our decisions every single day. At a more fundamental level, deep learning is a part of machine learning. The inspiration for deep learning is in the way the human brain filters information. It teaches a computer to filter inputs like images, text, or sound through layers to learn how to predict and classify data. Its purpose is to mimic how the human brain works to create some real magic. Now, what is deep learning? Like I said, deep learning is a part of the machine learning. And here it takes an input X and uses it to predict an output Y. Given a large data set of input and output pairs, a deep learning algorithm will try to minimize the difference between its prediction and expected output. Don't worry if you didn't understand these sentences, you will be able to get a clear idea in the following slides. So, this GIF clearly and very accurately predicts how a deep learning algorithm functions. This image is called a neural network. Each unit over here that you can see is a neuron, and each neuron performs some mathematical computation to provide an accurate output. So what is happening over here is that this neural network is taking an input in the form of an image. Over here, it is a dog, and it has to properly classify whether the inputted image is a dog, cat, or some other animal. As you can see, the neural network rightly outputs a dog. So, what is a neural network? A neural network is something which is composed of neurons in very simple words, and each neuron is the brain. It performs simple computation to get an accurate output. Now, how does this neuron exactly perform the mathematical computation and then give it to the next layer's neuron? There is a simple formula which is y equals to w into x plus b. Y is the output of the neuron, W is the weight of the neuron, and B is the bias of the neuron. Now, W and B, don't worry about these values. There are some fixed values and some fixed units that are given to each neuron in order to compute the output. You will learn about this in more detail in the following videos. So, X is the input from the previous neuron, and then this particular neuron will multiply that input with the weight and add the bias and then produce an output. Does this equation look familiar to you? It's an equation of a line, and it's the slope-intercept equation where W is the slope and V is the y-intercept. Now, in the previous slide, we saw how there was a single input to one neuron, but there could be multiple inputs to this single neuron. And if there are multiple inputs, there must be multiple weights as well. But the bias per neuron remains the same. So then our formula to calculate the next inputs, the next layer's input, which is this particular neuron's output, will be in this way. Y equals to W0 into X0 plus W1 into X1 plus W2 into X2 plus B. Thank you so much for watching.